Hello students, in this video we are going to solve few LCM and HCF important word problems for exams. These word problems are for all grades from class 6 to class 10. So question 1 is, two numbers have HCF of 12 and LCM 180. If one number is 36, find the other. So for this we'll first write what is given in the question. So given is HCF is 12. LCM is given as 180 and one of the numbers is 36 and we need to find the other number. So for this we are going to use a formula which is LCM times HCF equals product of the numbers. So LCM is given as 180 times HCF is 12. We have one number as 36. Let's say the other number be x. So we'll find the other number which is x. This will become 180 times 12 divided by 36 equals x. Find the value of x. We'll divide 36 on both the sides. So we'll get 180 times 12 divided by 36. We can now simplify it. This is 3 times 1 and 3 times 2. And 3 times 6 is 18. So 3 times 0 is 0. Again 12 times 1 and 12 times 1. So the value of x is 60. Or the other number is 60. So our final answer will be the other number is 60. We can even verify using the two numbers. We have 36 and 60 as two numbers. And if we find the HCF of the two numbers, we should get 12 as the answer. Or if we find the LCM of the two numbers, we should get 180 as the answer. We can verify the answer using this method. Now let's do question number 2, which is find the smallest number that when divided by 15, 20 and 25 leaves remainder 5 in each case. So let's write the numbers. The three numbers are 15, 20 and 25 and remainder is given as 5. So first of all as we need to find the smallest number, so we are going to first find the LCM of the three numbers. LCM of 15, 20 and 25. That will be the smallest number. So the LCM of the three numbers will be the smallest number. And then we need, as it leaves the remainder of 5, so we are going to add 5 to the number. So let's first find the LCM of the three numbers. So 15, 20 and 25. So let's use 3 to divide 15. 3 times 5 is 15. 20 is not fully divisible, so we'll write it as is, and 25 too will write it as is. Now we can use 5 to divide the three numbers. 5 times 1 is 5, 5 times 4 is 20 and 5 times 5 is 25. Now we can use 5 to divide 5. This is fully divided. 4 will be as is and 5 times 1 is 5. Now we are going to use 2 to divide 4. 2 times 2 is 4 and then 2 times 1 is 2. So all the numbers are fully divided. So LCM will be the product of all the numbers on the left hand side of the ladder. So LCM will be 3 times 5 times 5 times 2 times 2. So LCM equals 3 times 5 is 15, 15 times 2 is 30, and 5 times 2 is 10. So 30 times 10, which equals 300. So the LCM of the three numbers is 300. So the smallest number to leave remainder 5 will be 300 plus 5, which equals 305. So this is our final answer. So this is how we are going to solve question number 2. Let's see what's question 3. Question 3 is the HCF of two numbers is 8 and their product is 768. Find the LCM. So here in question 3 we have been given the HCF as 8 and product of the two numbers is given as 768. And we need to find the LCM of the two numbers. So here too we are going to make use of the formula, which is LCM times HCF equals product of the numbers. So LCM we don't know, we are going to write it as LCM. HCF is given as 8 and product of the numbers is given as 768. So LCM will be 768 divided by 8. Let's divide the two numbers. 768 divided by 8. 8 times 9 is 72. 4 is remainder. Then we'll drop down 8. And 8 times 6 is 48. So the LCM is 96. This is going to be our final answer. And this is how we find the LCM when HCF and product of the numbers is given. Let's solve question 4, which is question 4 is 3 bells ring at intervals of 10, 15 and 20 minutes. If they ring together now, after how many minutes will they ring together again? So for this question 2, we are going to first find the LCM of the three numbers 10, 15 and 20 minutes. Because every 10, 15 and 20 minutes, the process is repeating or the bell ringing is repeating. So let's find the LCM of the three numbers 10, 15 and 20. So 10, 15 and 20. Let's use 2 to divide 10 and 20. 2 times 5 is 10. 15 will be as is. 2 times 10 is 20. Now we can use 2 again to divide 10. 5 will be as is. 15 will be as is. 2 times 5 is 10. Now we can use 3 to divide 15. 5 will be as is. 3 times 5 is 15. And 5 will be as is. Now we can use 5 to divide 5. 5 times 1 is 5. 5 times 1 is 5 and 5 times 1 is 5. So the LCM will be product of all the numbers which are on the left hand side, which is 2 times 2 times 3 times 5. So LCM will be 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So LCM is 60. LCM is 60, therefore our final answer will be the bell will rings after 60 minutes. Let's solve question 5. Let's see what question 5 says. Question 5 is find the greatest number that divides 306 and 657, leaving remainder 9 in each case. So this question is same as question 2. Here we have to find the greatest number, and in question 2 we need to find the smallest number. To find the greatest number, we are going to find the HCF of the two numbers 306 and 657. So the numbers are 306 and 657 and remainder is 9. So to find the highest common factor of the numbers, we are going to subtract remainder 9 from each of the original number first, and then we'll find the highest common factor of the numbers. So first we'll subtract 9 from 306. Subtracting 9 from both the numbers. So 306 minus 9 equals 297, and 657 minus 9 will be equal to 648. Now we are going to find the HCF of 297 and 648. So finding HCF of 297 and 648. So let's divide 297 first. It is divisible by 3. 3 times 9 is 27. 2 is remainder. 3 times 9 is 27. Again we can use 3 to divide 99. 3 times 3 is 9. 3 times 3 is 9. 3 times 1 is 3. 3 times 1 is 3. And 11 is a prime number. It is only divisible by 11. 11 times 1 is 11. So let's write the factors of 297 here, which is 3 times 3 times 3 times 11, or we can write it as in exponents form 3 cube times 11. Let's find the factors of 648. It is even number divisible by 2. 2 times 3 is 6, 2 times 2 is 4, and 2 times 4 is 8. 2 times 1 is 2, 1 is remainder. This becomes 12. 2 times 6 is 12, and 2 times 2 is 4. 2 times 8 is 16, 2 times 1 is 2. Now 81 is divisible by 3. 3 times 2 is 6, 2 is remainder. This becomes 21. 3 times 7 is 21. 3 times 9 is 27. 3 times 3 is 9. And 3 times 1 is 3. So the factors of 648 will be 2 times 2 times 2 times 3 times 3 times 3 times 3. So in exponent form it will be 2 cube times 3 raised to power 4. This is 648. So we can find the HCF of the two numbers by finding the common factors in between the two numbers. So the common factors are 3, 3, 3. Here too 3, 3, 3. So 3 cube is common to both the numbers. So HCF of the two numbers will be 3 times 3 times 3, which equals 27. So HCF of the two numbers will be 27. So the greatest number or the highest number that divides 306 and 657 after leaving a remainder of 9 is 27. So let's write our final answer. The greatest number that divides 306 and 657 leaving a remainder of 9 is 27. So this is our final answer. We are going to box the answer, and this completes our last question. So let's take a look at the solutions of these word problems based on LCM and HCF once again. So I hope this video is helpful to you. If you like the video, please hit the like button and subscribe to my channel for more math videos. Thanks for watching.